Everyone, welcome to your Play Pause It for today. We're going to be covering some more examples from 3.05. That is our congruent shapes lesson. So go ahead and grab your notes, have your OMHS Play Pause It graded assignment, and let's get going. A few reminders though that we have something really cool coming up. I know that you guys last week, I'm sure some of you attended some of our Science Week sessions, and so we have some more virtual outings coming up for you guys. And the next one is going to be this Friday at 11 o'clock, and it's our virtual farmers market. So it's so cool, calling all farmers, gardeners, bakers, woodworkers, crafters, come show off your hard work at the virtual farmers market. So if you have something that you want to share, if you raise animals, you bake bread, cookies, cakes, grow plants, vegetables, any crafts that you might make, we would love to see them. And so those submissions are due actually by October 28th. So that is Tuesday. So you want to make sure to get those in to this submission form. I know that you guys have been getting this information from other places, so hopefully you have that link, but I will try to put it in the Play Pause It so you can also click it. So I hope to see you guys there. If you do not submit anything, that's okay. You can still come and hang out and see what your classmates have submitted. I know that's what I'm going to do. The next thing we have coming up, and this is going to be Friday as well at 1 p.m. And you guys will see all of these on your schedule for you to click into the session. The 7 mindsets to live your ultimate life. So this is held by our counseling team. It's going to be a great session for everyone to come. And they said that they're going to randomly pull 10 students to win an Amazon gift card. So that's kind of a fun enticement to come to the session. And I'll be there as well. So I hope to see you guys there. A quick reminder for us, and after November 6th, remember you will no longer have access to retake any graded assignments that were assigned on your plan from the beginning of the year until that date. So this is what's called our first end date. So that means you want to go ahead and complete any missing assignments that you might have that have zeros, review and retake any low graded assignments. And then of course, I'm always here, you guys. Send me an email if you need any help at all. I'm here. But you want to make sure to get this done before November 6th. That's kind of why I'm reminding you. I don't want anybody feeling rushed up until the end. So if you feel like you're a little bit behind or you do want to retake some things, go ahead and get started on that now. And please reach out if you need any help or you want some help sort of prioritizing the assignments and just wondering what maybe you should do first. Send me an email. I'm happy to help you with that as well. All right, so you may have seen this on your plan already, and you may have seen it on our announcement section, but we do have an extra credit opportunity, and it's digital pumpkin carving. So much fun. It's through Desmos. So in your plan and on the announcement section, you'll be able to click this link. This information is exactly what's there. So you'll click the link, and you'll use your first name and last name. If you guys don't use your first name and last name, I won't know who to give the points to. So please don't use any nicknames or anything like that. I want to know. I mean, you can put your preferred name. That's fine. I know some of you have different preferred names, but make sure your last name is the one that matches in the system as well. And then you'll see 2 slides. You'll be able to do an example on the first slide. And then when you click to create your own pumpkin challenge, it will let you design your own pumpkin. And you can even pick the size and shape and color and all that. It's really fun. One thing, you do not have to create an account. No, no, no. You can just click here. It says continue without signing in. If you want to create an account, you can. It'll just sort of save all of your Desmos activities that you do throughout the year. It's totally up to you, but you do not have to. You just click right there where it says continue without signing in. Be creative, have fun. This is optional, but it is extra credit. So if you've ever wanted any of that or been asking for it, now is a chance. It is due by October 30th. So that is this Friday by midnight. You guys know I don't want you working at 11 p.m., right? Basically, it just means you have the full day to do it, to complete it by that day. All right, so let's get into it. We're going to be covering OMHS lessons 3.6 through 3.8. And that, I'm sorry, actually it was 3.5. This should say 3.5. There we go. And I'm missing my picture. Where did it go? It's like it disappeared. Here, I'll draw one for you. You guys know I usually have like a fun little meme here. And I'm obviously not the best artist in the world, but here's my picture. Okay, we're going to review CPCTC. Do you guys remember what that stands for? That stands for corresponding parts of congruent triangles are congruent. And it's not just triangles. It really should be shapes. CPCSC. Corresponding parts of congruent shapes are congruent. So this statement here is really powerful. This is called our congruence statement, and it tells you everything you need to know. So this is review from one of our other play posits. So we can label the first triangle FLX if we want, and it doesn't really matter where we put the letters on the second one either. I could start Z here, ZAQ. But now let's mark the triangle up. This congruence statement, remember this means congruent. Congruent means they have the same size and the same shape, right? These are both triangles and they both appear to be the same size. That's what congruence means. It's basically the definition of congruent statement of congruent shapes. They're not equal because it's not the same exact shape, right? Like there's one here and there's one here. It's like twins. Like if you have twins, they're not the same exact person, right? But identical twins are basically congruent. We know they're truly not because they're human, but that's an example to relate to geometry. All right, so we know FL is congruent to what side over here? So we use this congruent statement to match it up. F and L are the first two letters in this triangle, and they match up to the first two letters over here, ZA. Boom. See, it's not always going to be oriented the same way. It's not ZQ. You want to go with the order that the letters are written in the congruence statement. All right, next is LX, and that matches with AQ. So LX and AQ. And then, of course, lastly, we can just mark the last side because we know it matches. But it's FX, the first and the last, and ZQ, the first and the last. All right, we can do the same thing with the angles. Angle L, that's the middle letter. So that's going to match with the middle letter over here. That's angle A. So they're going to get the same markings. Angle F, that's the first letter. That matches with the first letter over here. That's Z. They'll get the same markings. And then the last angle, angle X and Q, the last letters in that congruent statement. So you can see it's really powerful because if I had said, oh, this is 4 units long, and I wanted you to find ZA, you could very quickly match that up. Oh, they're congruent. They're the same. And we're going to use that now in some of these examples coming up. Don't forget, I know I've said this before, but because this is a recording, remember you guys can pause at any time. If I'm going too fast, you can pause and fill in your notes. If you want to try the examples on your own and then click play and get the answers, that's the beauty of a recording. So here's example 1. It wants us to complete the congruence statement down here. Triangle EDC is congruent to which order of letters over here? All right, so it's going up. E, D, C. So we're going to match up the values. So look, ED is 26. That matches with the 26 over here, WX. DC is 41, so that's going to match with XY. And then, of course, the last one, right? So we need to go in the same order of tick marks, or the same order of measurements. So this one went EDC, E to D to C. So they went right past the 26 and the 41. So we need to start where we're going to go past the 26 and then the 41. Order matters greatly. So it's going to be WXY. Order matters so much here, just like we saw on the last slide, because we use these letters to match up the congruencies. Now we can check this if we wanted to. Let's check the angles. Angle E and W should match up. Well, let's see, E is 79 and W is 79. Angle D and X should match up. D is 63, X is 63, and then C and Y, 38 and 38. So our order checks out. So you can also use the angles to do your order as well. Let's try another one. Complete the congruence statement. So they went NMO. So N is 59. Let's use the angles. NMO. I just ordered them in the order that they went. So let's come over here and order them the same way. 59 is number 1. 78 is number 2. 43 is number 3. Cool. So that tells us the order in which to write the vertices. 1, V, W, X. V, W, X. Are there other ways to write congruent statements? I wonder. Like, what if I wanted to write triangle OMN? OMN. What triangle would that match up with in a congruent statement? OMN. They went angle 3 to angle 2 to angle 1. So let's go angle 3, X, to angle 2, W, angle 1, V. This is totally accurate. Just another way to write a congruent statement. As long as the angles match up and the side lengths match up, you can do it in any order. All right, example 3. They give us the congruent statement this time, and they want to know what is the measure of angle W. So if you come over to this triangle, we're looking for this angle measure. And if you just had this triangle, you would not be able to figure it out, right? Because you only have one angle. We're missing 2. So we're kind of at a loss. So that's when the congruent statement is going to help us immensely. So what does angle W match up with in the first triangle? Well, angle W is the first letter, and Q is the first letter here. So let's go to angle Q. Ooh, we know because of this congruent statement that those angles are equal. So if Q is 63, that means W has to be 63. That's why the congruent statement is so helpful. Let's try example 4. These figures are congruent. What is the measure of angle E? So we're looking for this angle measure. It's a funny thing about this example. There's 2 ways we can do this. If you look at this triangle, we know that the triangles are congruent, right? So we're able to match up the angles. So we know that T and D match up, right? Because they're labeled. But over here, neither of them are really labeled. But V kind of is, right? What does this square represent? 90 degrees. So because over here, this is 37, we know this one's going to be the 90. Like it's the only one left, right? 90 degrees. So you can use that fact that they're congruent, or check it out. This triangle already has 2 angles. So remember, whenever you have 2 angles in a triangle, you can always find the third. Remember, triangles add up to 180 degrees. So if the total is 180, we could just subtract out the 2 angles there, and we would get 90, the third angle measure remaining, 90 degrees. So this one was pretty cool. There's 2 ways to do it, 2 ways to solve it. And I'm telling you that either way is totally fine, whatever way your brain sees. Example 5. These figures are congruent. What is the measure of angle R? So we're looking for R. This time, we only have one angle measure, right, in this triangle. So we can't use the triangle sum theorem. We can't add up all the angles to equal 180. So we have to use the fact that they're congruent. Let's try to match these up. W is 56 and Q is 56. So we can use a little bit of logic here, right? Obviously, the 34 is going to go here because this angle is obviously acute. It is. We don't know how acute it is, but it is because it's definitely less than 90. So that would make this one 90 to match those up. So we were looking for angle R, and R is 34. So we used a little bit of logic there. I know I tell you guys all the time, like, diagrams are not drawn to scale, and you don't know for sure, but we do know for sure that they're congruent. So we're able to match up those angles using our logic. All right, example 6. This time they give us the congruent statement. I love that. And it wants to know the side length of SQ. So all you got to do is you got to go to the congruent statement. So it wants SQ. We don't know anything about this triangle other than the fact that it's the same as this one. So SQ is the first and the last. So we want the first and the last in the first triangle. We want FH. So just go find FH. Here it is. So we know they're congruent. It's 33 inches. We can match up the other ones too. Let's do it. GH is the second and third letters. So RS. GH and RS are congruent. And that leaves the last side, right? Cool. Kind of like a matching game using this very powerful congruence statement. Example 7, are these shapes congruent? Remember the definition of congruent. What are the two things? The same size and the same shape. So the same size meaning they have the same angle measures and the same side lengths. That's what makes it the same size, right? Because if the angle measures were not the same, well, we'll see in example 8, then it wouldn't be the same size, right? It could be bigger or smaller. Same with the side lengths. So we know that these side lengths are the same because of the tick marks. They're all congruent. Same with over here. We know the angle measures are the same because they're all labeled. That's nice. They're all 108. So yes, these shapes are congruent. They are the same size and the same shape. These are actually called, right, how many sides? 1, 2, 3, 4, 5. 5 sides. This is a pentagon. This is actually a regular pentagon. We're going to talk about this more in another unit. But a regular pentagon means that all the sides are the same and all the angles are the same. See? All the sides are the same and all the angles are equal. It's a special shape. Here's example 8. Are these shapes congruent? So we have two squares here. You guys know squares have 4 congruent sides. So even though these aren't marked, we know they're 25. That's the definition of a square. And even though these aren't marked, we know that they're 20. I'm using 2 marks here because I used 1 mark in this diagram. And it's the same sort of all one problem. So they are the same size. I'm sorry, they are the same shape, right? But they're not the same size. And what confirms that is that the left square is 25 miles and the right square is 20 miles. So the one on the right is obviously smaller. So no, they are not congruent because they are not the same size. All right, example number 9. What values for x and y make the triangles congruent? So again, that's a very powerful statement. Now we look at this one. This is the first one where we've seen some variables. I see an x here, an x here. There's some y's. And it wants us to solve for both x and y. If you see the answer choices, we want to solve for x and y. So what does this mean? This is that powerful statement. It means that the sides are the same and the angles are the same. So let's mark up the pictures. I think that will help. So MN is congruent to what? PR, right? NO is congruent to RT and the last side. So now let's just sort of pull off the information. The one tick mark side is 3x minus 9. And we know that equals the one tick mark side over here, 24. So in the last examples we've seen just straight values, right? If this was 24, then we would know this whole thing is 24. They don't want to know the side length, they want to know x. So we're going to use the congruent statement to set up that equation. And now let's solve for x. And we're going to do the opposite of -9 and add 9 to both sides. That's that addition property of equality, right? And this is, what is this? Is that 33? Yes. Cool. Now we'll divide 3 on both sides, that division property of equality, and we get 11. So x is 11. So we know it's not going to be C. We know it's not going to be D. All right, let's find y. Y is involved in the angle measures. So which angle matches up with angle N? That's the middle letter. So it's the middle letter over here. So that's going to be angle R. So let's write that equation. We know they're congruent because the congruent statement tells us they are. 1.5y equals 41.4. So we can divide both sides by 1.5. I don't know about you guys. I'm grabbing my calculator. Let's see. 41.4 divided by 1.5. And I got 27.6. Ooh, it's looking promising that it's going to be B. I mean, we would assume, but let's just double check. There's one more thing to do here. We don't have to, but we might as well. We have time. There's another y right here. So we have another option to solve for y. This is angle T. So angle T is the last letter, and that matches with the last letter over here. That's angle O. So let's just set those equal and see. Ideally, we're supposed to get the same y value because the shapes are congruent. So let's make sure we do. Let's see, 82.8 divided by 3. Woohoo! Happy dance! 27.6 as well. So it is in fact B. If we had gotten another y value here, then I would suggest that we would go back and double check our work because they should absolutely be the same because of the congruent statement. And just a heads up, this is an actual SOL question that I pulled from the latest release test. So that kind of gives you an idea. You know, I'm not trying to teach you to pass the test. That's not my goal, never ever. But I do want to show you the type of questions that you're going to see so you can be prepared. All right, here's our last example for the day. It tells us that the two triangles are isosceles. If we remember, isosceles means that there are two equal sides. And the diagram does a great way of noting that, right? That each of these triangles have the two equal sides. And they're equal to each other. In addition, because of this congruent statement. What measure of angle P could be used to prove this? So they want us to find angle P. All right, so let's work through this one. We can really only use the information we have so far, right? We only know M and Q. So if we're going to assume this congruent statement, then see how M and Q are in the middle. So we would assume that they're congruent. So let's see, that would mean that these are equal. So let's solve for x. We'll subtract x from both sides and add 26. Do that in one step. So we would get x, right? 2x minus 1x is x equals, what is this? 42. All right, x is 42. So what does that make our angle? So I'm going to plug in 42 here for x. Let's see what we get. 2 times 42 minus 26. So I get 58 degrees. And this should also be 58 degrees, right? Because we set them equal, but we could just confirm 42 plus 16. I'm just plugging in 42 for x. That is, in fact, 58. Perfect. Okay. Now you might be like, now what do we do? We're kind of stuck. But we have to use the idea of isosceles. So this is, excuse me, this is actually something we haven't talked about yet. This is kind of exciting. But I also want to say don't worry because we're going to do like a whole lesson or half a lesson on this. But with isosceles triangles, when the sides are equal, it also means that the angles across from them are equal. It's the property of being an isosceles triangle. And it makes sense if you think about it. If those two sides are going to be the same, and if I was in person right now, I'd have some popsicle sticks or something to show you that these angles are going to have to be the same as well, or it would not form a triangle. So that means these two sides, since these are equal, the angles across from them are also equal. So if they're equal, let's label them the same. We don't know what they are, right? But when you don't know what something is, what could we use to label it? Let's label it as X. We don't know what it is, so we'll call it X. And I labeled them both as X because they're equal. They're the same. They're congruent. Now, last step. Let's use the triangle sum theorem that all the angles added together equal 180. 58 plus X will equal 180. Now let's solve for X. That's going to give us the angle measure. That's going to give us P. We could have used this side as well, X and X. So 58 plus 2X equals 180. Subtract 58 from both sides. I'm grabbing my calculator just to be sure I don't have you guys here to help me. 180 minus 58 is 122. And then we'll divide by 2. And I got 61. So the angle measure is 61 C degrees. We could have used the right triangle as well, and we would have gotten the same thing because they're congruent. So the big thing here that we use that might be super new to you guys is when two sides are equal, it also means angles across from them are equal. All right. Well, again, we're going to do more of this coming up. That's it. It was a short one today. You guys reach out to me with any questions. Please check your email. I sent you and your learning coach an important update for our class, just some reminders. I wanted to make sure that you got it. Bye, everybody. See you on Thursday.